Alrighty, so in the last video, we talked about this idea of the XY plane and navigating through this. And this was sort of a soft introduction into linear relationships, into the topic of linear relationships. And this video is going to serve sort of as like a part two of that soft introduction into it. But we're going to be talking more about essentially some of the definitions of linear relationships, what we actually mean by this, and starting to approach these different types of relationships. So I've written an expression here, which is that y equals 2x. And I just want us to first start by just making some observations about this. Well, at the moment, based on all we know, this it sort of looks like an equation. We have one thing on the left hand side equaling the other thing on the right hand side, but we can't really solve this for anything in particular, can we? Like with our equations, we previously would have had, say, I don't know, 2x equaling some number, and we can find a value of x that satisfies that. But here we have two unknown things. We have a y and we have an x. And we call these things variables. And linear relationships, this topic is all about the interaction and the relationship between these two variables along our xy plane that we introduced in the last video. So this topic is more or less just looking about, we are looking at how one variable changes with another. Now, let's actually unpack what I've actually got here. In actual, worded terms, all we're saying here, well, y equals 2 lots of x. So, writing this sort of in a sentence, we can say that y is 2 lots of x, or just 2 times x. So in essence, y is going to be, whatever x is, y is always going to be 2 times that. So y will always be double that. And we're going to look at how this actually translates onto the XY plane we introduced in the last video. So what we're going to do first is we're going to take these ideas and this kind of this YX relationship, and we're going to draw up what we call a table of values. And this is just something that's going to give us an idea, a nice, succinct way of showing how one changes with the other. So I'm going to draw this table here. I'm going to put my x, I'm going to put my y. And I'm just going to select a couple of values here. So I'm going to go all the way from negative 2x to positive 2. Well, sorry, x is equal to negative 2, or x is all the way up to x equals positive 2. So here we have that y is always 2 lots of x. So for x equals minus 2, well, y is going to be 2 lots of that. So we're going to get minus 4. For negative 1, 2 lots of negative 1 is negative 2. Well, 2 lots of 0 is just 0. 2 lots of 1 is 2. 2 lots of 2 is 4. Now, let's take a moment to just understand what's actually happening here and look at how these y and x variables change. Now, what you may be able to notice is both y and x here, well, they're moving, they're changing by different intervals. So x is going up by 1. And with linear relationships, we're always measuring y in relation to x. So x is kind of just going to change as it goes. It's just going to change sort of willy-nilly. Sorry, that's a little Australian expression. I don't know if anyone's picked up on that, but what I mean by that is x is just going to change freely. we're pretty much just plugging in different values of x into here to see the effect that that has on our y. That's the relationship we're examining here. So in this case, our x is going up by 1 always. Now, x is sort of constantly, it's going up in a very uniform manner. It goes up by 1 from -2 to -1 to -1 to 0, etc., etc. And now y here is moving up by 2 for every x movement of 1. So between, say, here and here, when x has gone up by 1, well, y has gone up by 2 because we're adding 2 to -4 to give us -2. Same in this kind of region. When x is -1, my y is -2, and going up by 1 in the x results in a change in 2 in my y, and so on and so forth. Now, this is quite important because when we actually graph these, the fact that my x and y change in a uniform manner, no matter whether the intervals and the way the numbers are changing, they are different, but they're going up in the same increments. So x is going up in the same increment of 1, and y here is going up in the same increment of 2. Now, we're going to take these values and we're going to graph them on our xy plane. Now, we're going to plot all of these points here. Now, we talked about this a little bit in the previous video, so I might go a little bit quicker when we get to here. So drawing this, we have that, well, when x equals -2, so -2 on the x plane, well, y equals -4. So finding where these meet on our little xy map, they meet here at this point. This point, -2, -4. And we're going to continue along this trend. So when x is -1, y is going to be -2. So we have this here. And when x is 0, y equals 0. That's just at the origin here. So we call the point when x is 0 and y is 0, we call that the origin as given by this letter O. Now, when x is 1, y equals 2. So we are going to draw that in here. And when x is 2, y equals 4. So we're going to draw that in here. And what you will notice, the fact that both of these move in a uniform manner, this will always result in a linear relationship. In other words, when we plot the points, we will get a straight line passing all the way through. And I've done these arrows just to show that this is going to kind of reach out all the way to infinity, pretty much. This line will continuously go in this fashion all the way through. So when x equals 3, for example, well, y will be 2 lots of that. So it'll be 6. So it'll be somewhere kind of somewhere up here. Same with the negative direction. That's going to be somewhere down here. And this is kind of a soft introduction into linear relationships as a way of looking at how two variables change with one another. And this is evident in my graph because I get a kind of constant change happening, that for every 1 unit of x I go across, I go up 2 units in the y. When I go across 1 in the x, I go up 2 in the y, and so on and so forth. Now, in the next video, we're going to look at how this will change for different types of linear equations, these different types of 2 variable equations. I'll see you then.